Hello everyone, I am MeriamDjerad, architect and doctoral student in Arts and Mediation Design specialty at the Higher Institute of Arts and Crafts of Sfax of Tunisia. Before starting, I would like to thank the organization committee which watched over the smooth running of these days, as well as the scientific committee for the time allocated for the evaluation of our works. Thank you very much. This contribution, titled Conceptual Process Model for Metaverse Architecture, SSADT's design process, is developed in collaboration with my co-thesis director, Dr. Sonda Kamoun, Master Assistant at the Higher Institute of Arts and Crafts Aspects of Tunisia. I thank her very much. I'm honored with this collaboration. This presentation is divided into 5 parts. Before the introduction, we start by the global operation of the blockchain application, then the modeling steps, next the result, a conceptual design process for an SSIDT, and finally the main contributions. Digital twin lives and evolves in a computer like a virtual avatar. It is considered like a compound of metaverse architecture. Relatively new to architecture is becoming a desirable prospect, as it offers a possibility to build a fair clairvoyance for all the actors in the static and dynamic state of a project. It is a catalyst for increasing the collective intelligence, and it can ensure a digital continuity during the life cycle of a project. For its implementation, two key compounds were defined: a collaborative platform and a process of co-evolution. The backbone of the digital twin, blockchain technology, is a key to the development of such platforms. It's laying the foundation for a new decentralized internet, and it is a key pillar for an engaged and responsible digital transformation, and it enhances trust, proof of provenance, collaboration, transparency, efficiency, data sharing, and information security. The main purpose is to establish a conceptual process for an architectural digital twin, and we are pointing to a shared and secure one, SSADT. Interoperability, security, and transparency are the key concepts and the major challenges for our process. Therefore, to meet the challenges, we have thought of relying on blockchain technology to design our process model. So, what process model could we propose for the design of shared and secure digital twin? At what level could we integrate the application of blockchain in the design process, and what could be the impact of such a digital twin on design processes? Before explaining the modeling steps of the process, we have to define the phases of our process model. But let me start by explaining the global operation of blockchain application at a private workspace. At the beginning of each new project, architect is charged by creating a new project file and defining the teams of actors for each phase. Secondly, each actor will then receive his own account and access key to the workspace to which he is entitled. Then he creates copy of the project. These copies are checked and validated by a cryptographic techniques. After validation, a new block is created and added to the chain. The blockchain is then distributed to all actors. The block is received by all actors. It has to be approved by all stakeholders to be shared. After validation, a blockchain network is then created. So we have to define our phases. We define 4 phases. The first one, each phase corresponds to a block. The first phase is a problem formulation. It contains context data, constraints, and objectives. The second phase is the development of possible solutions, and it contains morphology researches, the researches related to function and the communication and configuration, and of course the solution from the first phase. The third phase is the system behavior simulation, and it contains the material flows, the energy flows, and the information flows, and of course the solution from the second phase. The fourth phase, which the final phase, it contains the formulation of the optimal solution, and it contains the qualitative study, the quantitative study, and the heuristic study, and of course the solution of the third phase. Each phase corresponds to a private space of a team of predefined designers. In each phase, we have to define problem to arrive at a solution. As a result, each workspace has its PST mark delivered at the end of each phase. So now let's move on to the phase operation. Each phase therefore corresponds to a block which contains its specific data at the solution received from the precedent phase. At the end of each phase, a solution is delivered with its justification. The deliverables are deposited in a space for validation and justification. This area is accessible by all actors. Two cases are possible. In the case of incoherence or an anomaly, the solution will be sent back to the previous phase for revision and reformulation. This is a negative feedback. In the case of validation, the solution is transferred to the next phase. Two cases are also possible. Two cases are in the absence of anomaly, the solution is delivered and it will be readable on the platform by everyone, namely customer and public institutions. Otherwise, another negative retro control is also possible. This operation is related successfully. As a result, we have our process model for NSS ADT. At the end of the fourth phase, we can use the model to target our SSEDT, learn from it, and design again in the B1, reformulating the problem, or make decisions that allow action in the physical twin. As you see, we have not indicated the direction of the relations in the model because we think that it must be characterized by the designers. It can be one way or two way. This will give our model flexibility to adapt the nature of the project. There may be different hierarchical or nested relation network in subsystems. In all cases, we try to offer a subjective freedom to designers and architects to ensure a continuous balance between the logic imposed by the rules prescribed by the specification and the creative logic of the innovation. At the end, we consider the blockchain technology promising in the field of architecture. It paves the way for a committed and responsible digital transformation in the field of architecture, and it is possible to adopt participatory approach in the design process while ensuring a fair foresight to all stakeholders in the state of the project in real time, the data security, and the respect of intellectual property. Before finishing, I would like to express my thanks to my thesis director, Professor Iqbal Sharfi, for encouraging me to perfect this work. And thank you for, for your attention, and I am happy to take any questions.